All right, everybody. So, welcome back to another episode of Spooky Software. Today's going to be hopefully a little quick, nice, cool tidbit. We're going to be talking about something called Tree Sitter, which is kind of combining a couple of my favorite topics. So, we're going to talk a little bit about programming languages as well as text editors and dev tools. So, this should be just a cool little fun thing to think about as far as augmenting your developer experience. So anyway, what is Tree Sitter? Why am I talking about it at all? Tree Sitter is here's the documentation website that I found through the GitHub. I'll be sure to link this in the video description, but essentially it is a parser library, right? So this is a thing that can read text, right, and turn it into like a syntax tree, right? And so we'll take a look at this a little bit later, what exactly I mean by that. If you're not like a programming language person or you haven't written a compiler either for school or something, this might be a little new to you, but essentially, right, things like compilers and interpreters want to turn text into something more structured, right, so that they can do their work, right? But Tree Sitter is a little bit unique because it's not really aimed at compilers or interpreters. It's actually more likely to be used in things like text editors, right? So if we think about text editors, they kind of want to do the same thing, right? There's some text inside of a buffer, and they want to do things like syntax highlighting or folding, or maybe like sort of some high-level features like switch to arguments orderings or something like this. We want to manipulate source code, right? So we need to be able to parse it, right? And actually, what's interesting is that most text editors, the way that they parse text is relatively simple in the sense that they usually just use things like regular expressions to get their work done. And for most kinds of things, it kind of works out. But regular expressions have their limitations, and especially for more complex programming languages or that can come in many different shapes. It's not ideal, right? And we'll talk a little bit about how regular expressions can go wrong later. But anyway, Tree Sitter is a library. It's written in like C and Rust and some other things that you sort of embed in another application like a text editor. You may also use this for like something like a language server protocol or something else that needs to parse source code. But this is sort of the first thing. And I believe this is like a GitHub project, like the GitHub, the company. And I think the first sort of real application of this was in the Atom text editor. But I believe also, GitHub.com uses Tree Sitter for things like, maybe some of the syntax highlighting that happens on the website, or maybe parsing source code to, add bookmarks to certain things or things like this. But so we'll take a look in a minute about how exactly we turn source code into a parse tree. But before we do that, I just want to mention that this parser library, Tree Sitter, is programming language agnostic for the most part. And the syntax tree that it produces is just a common interface that things like a text editor, or more specifically even maybe like a color scheme, can identify. So for instance, it might turn JavaScript and C++ into things like function definitions and identifiers and things that a lot of programming languages have in common, right? Since it is programming language agnostic, the C library itself, it needs basically kind of like a grammar. What do they call it? They do call it a grammar. And so this is something that you would probably download with your text editor that has Tree Sitter built in. It looks something like this. So as opposed to something like a compiler or an interpreter, these are probably a little bit more simple because the kinds of nodes that you would have in this tree for something like a text editor probably don't need to be as complex as they would be for, say, a compiler or an interpreter. But you can see, I don't know what programming language this is, but the idea is that you write something like this. The way in which you write a grammar is actually using like a node library, and then this compiles into like C to be very fast. But you can see that like, a source file, is repeated many definitions. A definition is like, one of n things, right? So inside this programming language, it looks like there are function definitions. All function definitions start with the string func, and then there's, an identifier, some parameters, maybe a type, right? And then maybe what it returns, the block of the function, etc. Parameter lists have parentheses, and then there's something in the middle, etc., etc., etc. And so, you can build up like a complex programming language from sort of these smaller things. One of the interesting things about this, if you've ever used a parser combinator library, these built-in primitives, these functions are probably familiar to you, like sequence, repeat, choice, etc. But long story short, this is relatively high level, so it should be easy to concoct. And the other thing that's interesting is you can compose maybe other programming languages from another one. So, for instance, if you have a JavaScript grammar, you might compose your TypeScript grammar from that JavaScript, so you don't have to like re-implement. You can kind of just augment, right? Which is pretty cool. As a user of TreeSitter, like if you wanted to use this in your text editor, you wouldn't necessarily be messing with this kind of stuff. This would probably be provided for you. Some like, canonical TypeScript rules or whatever would be included with your text editor. But I just wanted to show it because I think that this is a relatively interesting and straightforward and high-level way to define how these different programming languages are parsed using the same parser library. And again, we're talking about things like text editor. So another thing that TreeSitter provides for you is it's pretty fast, right? So it can parse things, in basically milliseconds. And it also, in the same kind of vein as being fast, it does really well with incremental input. So, that's really great, especially for something like text editor where, when you open the file, you want to parse the whole thing. But as you're editing, you really kind of only want to parse like maybe the line or the bytes that you're on, right? And so it can do that. The data structures it uses internally kind of structurally share, so it really only changes small parts of the tree, which is also good for other things like concurrency, where we're not really mutating anything, we're just creating new things and redrawing lines where they need to go. Kind of in the same vein as this incremental thing, one of the things that's nice about TreeSitter is it's also pretty good at like kind of error recovery. If you are thinking of like a compiler or an interpreter, usually, compilers, interpreters, if there's a syntax error, they just kind of give a bellyache and throw up and then, stop, right? And give up, right? But for text editing, we can't really do that, right? As we're typing text, intermediately almost every keystroke, right? We're probably not going to have valid syntax, right? You open a double quote because you want to start typing a string, and until you close that double quote, you probably don't have valid, JavaScript, for instance, in that intermediate state. So, and we will take a look at this. TreeSitter is very good at sort of error recovery and having errors in the middle of this larger tree and being okay with that. It also does kind of like its best guess as to like what it thinks you're going to end up with at the end of the day to try to provide you the best experience in this intermediate sort of invalid state, right? And again, back to this like speed thing, it kind of comes back to this incremental or, kind of reparsing every keystroke, right? To give you the most up-to-date results is ideal. Some of these heavier IDEs and stuff will actually reparse the entire file every keystroke, or maybe only every other keystroke because they're so slow. And maybe if you're looking for fast feedback and good latency, you're not going to get that. Okay, so I'm not going to spend any time talking about this sort of the algorithms and how this parser library works, how it translates text into these trees. There is a great talk by one of the main authors, or maybe the author of the original TreeSitter library. It's a Strange Loop Hub. It's fantastic. If you're interested in parsing in general, there's lots of good stuff in there, as well as some of the things I'm saying here, but more in depth, right? So that's just a longer version of what I'm saying here. One other thing that this library provides, which is really useful, again, for sort of making it more general purposes, it also comes with a kind of a query language. And that's actually your interface to the library. So you can say things like, find me all of the nodes of this type, or, maybe find me all the functions that begin with this identifier or whatever. And I'll just show you an example of what a query might look like. So the program, the language that you use, it kind of looks like Scheme, like a Lisp-esque language, and you can kind of write these expressions, and TreeSitter will return you results. And if you are a text editor and you're trying to do something like highlight, or if you're a text editor and you're trying to do something like folding or whatever, you can use these expressions to manipulate, understand, and work with the structure of the source code that is being edited, right? And why this is interesting again is that this is one of the trends I see happening in computing these days is because our computers are getting faster. For instance, we are making this trend towards more structural data, right? So this text file is less text; it's more programming language, right? There's structure to it. There's expressions and statements and function definitions and parameters and stuff, and that's a structural idea, right? And we want to manipulate structure, not so much text, right? So anyway, let's actually hop over on my iPad. I'm just going to draw just a brief understanding of how parsing works, like what a syntax tree is, for instance, and then we'll go from there. Here I have written out a single line here of maybe JavaScript. Excuse my poor handwriting, but so this says const myvar equals 3 plus 2, right? And so this is something that you could have, in a text file, right? And if you're writing like a JavaScript virtual machine because you want to interpret this, right? Or if you're writing a text editor because you want to read this and syntax highlight it, right? You may like recognize this line of code as a statement, right? So that's why I've kind of grabbed this whole thing from const all the way over to the semicolon and said this is a statement, right? But also, again, we're going to focus on sort of highlighting and text editing, right? We kind of recognize this little part as like maybe like the declaration. So this is a const declaration, right? And we might want to highlight const as like, a particular color, right? This is an identifier, right? Or a variable, and so we may want to highlight identifiers in a particular way. These are literals, right? So these are numbers, right? Again, same thing. We want to highlight numbers in a particular way. This is an infix operator, right? And so we can see that a statement is composed of many actual smaller nodes, right? So a statement might have a decal type. It might have, this actually might be like a declaration statement, right? Which is of the type const, and the identifier is myvar. We kind of don't even really care about the equals necessarily, right? As far as structural information about it, we just care that the right-hand expression is 3 plus 2, and it is composed of an infix operator, and that infix operator has two, a left and a right, and it can kind of recurse into this tree, right? And so what this might look like in memory, for instance, is something like this. So we have this DS, which stands for declaration statement, right? And that is composed of like a type, right? Maybe like something like const. And then it has a identifier, which is in this case myvar, and then it has an assignment expression, and so that might be another subtree, right? So in this case, it's just a binary operator, which is of course the plus. Let's go ahead and erase that a little bit. Get that a little bit better there. Binary operator, which is of course the plus, and then that might have two subnodes, which is like the left and the right, And, of course, that is now a literal, which is, what was ours again? It was 3 and 2. So it's 3 and literal and 2, right? And so we have this tree here of things that, that actually make up the structure of this text, what it semantically means, kind of, right? And of course, if we were editing this text, if we were kind of changing this, right, maybe I decide, okay, 3 is not really what I wanted. I'm going to delete that character and I'm going to type in maybe another variable instead, like X, right? As we're changing this, there's a period of time where maybe my keystrokes delete the 3, right? And I don't have the plus, I don't have anything there yet. And so we don't want the text editor to kind of break in this intermediate step. We still want like the highlighting. We still want maybe consts to be highlighted in a particular way, maybe the identifier in a particular way, etc. This 2 still needs to be identified as a number, literal, right? So in this intermediate step, equals +2, that's not valid JavaScript, right? Until I type this X, it's kind of in this broken state. And so TreeSitter is really good at dealing with stuff like that, and we will see that more concretely in the text editor when we get there. But eventually, I kind of replace the 3 with this X, and so actually what we want to do is we want to keep this entire tree the same. We just kind of want to swap out this left and kind of replace it with a new left, which is going to be like another identifier. And that's going to be it's going to be the string X, right? So this is kind of the idea, and we will actually see this tree visually in the text editor later. I thought it might be just interesting to kind of draw it out this way at first, just to give you sort of a mental model. All right, so here we are. We're in just regular old Vim, right? Actually, in this case, we're using NeoVim. But, this is some TypeScript that I have just kind of filled in here for something, a little bit interesting, just giving us lots of different kinds of lines of code. Here's some of those statement declarations. We've got a type definition, a couple of functions with different bodies. This is interesting. This has got a bunch of data structures down here as literals, right? And some strings, etc., right? So this is sort of the out-of-the-box experience. I'm using some kind of color scheme. I can't remember the name of this particular color scheme, but Vim is doing like a pretty good job of highlighting this, right? It's recognizing that, hey, there's this purple thing called function, right? And then, the name of the function, crazy, right? I've made blue here, and all the parameters are yellow, etc. It even recognizes here like this property as a property. It's doing a pretty good job, right? But it's not super hard to break this, right? Because NeoVim, at least out of the box, uses regular expressions to parse this, there's some like weird things going on here. Like I'm not sure why this semicolon here is red. I'm not sure if that's like a whose fault that is or whatever. Or, a classic case that you see is something like this where, I type the beginning of a multi-line comment and now it's like highlighting my entire editor as like, oh, this is the comment body, but maybe I only wanted to do like up to here. And I've sort of like lost all of the syntax highlighting in the meantime. We can kind of get the same behavior, right, with these like multi-line strings, right? Again, like, it kind of thinks it's the whole string, and in some sense it's not wrong, right? But it could be potentially a little bit better, right? So let's actually, what I'm going to do is I'm going to turn on TreeSitter. I'm going to switch to TreeSitter as my parsing library. So to get this to happen in your editor, you'll have to like look up for your particular editor if it has TreeSitter support. So in the case of NeoVim, you'll have to get like the beta or the nightly version. In fact, in the nightly version of NeoVim, TreeSitter is the kind of the way to parse source code, right, and do syntax highlighting. But I'm going to turn it on. So let's actually do that. So now I've turned this on, right, and so it almost looks exactly the same, right? In fact, if you weren't like, okay, let's just turn it off again, and it's like you almost can't even tell, right? It's subtle, right? But we will start to get some different behavior right away, right? So for instance, like if I like delete this, right? And so remember in the previous thing when I was using sort of regular expressions, this didn't recognize that like, oh, I was in the middle of typing this long string and I didn't want to like delete, or I didn't want to count the next like 30 lines as part of this string, right? And so once I recover from that error, like now, I kind of get what I want, right? And so we can actually see the tree sitter syntax tree that I was talking about. So there's this thing called the Tree Sitter Playground. This is another plugin you can get. You probably would really mostly use this if you were going to develop something with Tree Sitter to sort of see what's going on. But this is a tree, right? So this is sort of a parent node, and then there's a subnode, and then that has some properties on it, and then there's more subnodes and whatever. And so as I move my cursor here on the right, you can see it's kind of identifying on the left, what I'm looking at. So for instance here, this lexical declaration, I called it a statement declaration before, but they called it lexical declaration. That's just their name for it. And you can see these numbers are like, what line and characters they go to. So this is line 0 indexed, right? The characters 0 through 21 are this statement here. There's a variable declaration. Half of it is the name, which in this case is an identifier hello, right? And that goes from 6 to 11. That's, H to the O. And then there's a value, which is a string on the right. And, I can kind of click around and I can see, different parts of this tree, right? And so now things like highlighting can be this tree aware. So what I mean by that is like, this color scheme is capable of identifying, oh, I should do things that are type identifiers. I should make them blue, right? And so throughout this entire program, type identifiers are always going to be blue. It has nothing to do with the fact that this is the character T, right? And in fact, that's actually a really good instance because node is and T are like sort of user defined types. They're not built-in types like string, right? So we don't want to necessarily highlight string and node differently just because they're built in or not built in, right? And if we were using regular expressions, we'd have to have some kind of like weird regular expression thing where it can identify places that types go to recognize user-defined types, right? But here, again, since we're operating on an actual tree that sort of understands a lightweight version of TypeScript, we are able to do very accurate syntax highlighting, right? So again, and I just want to show this sort of error handling business. So again, I'm going to break this string. I'm going to delete this thing. And you can see that over here on the right, it's like encountered this error, right? This is not valid TypeScript. It doesn't really know what to do, but it's trying its best, right? It's giving me a guess. By the way, it hasn't broken the rest of the tree. In fact, you can even see that the rest of the tree remains exactly the same. It's just this kind of like one little section of the tree. As I'm incrementally typing this thing, it throws an error. And then it can recover from this, and it's guessing that it thinks this is an identifier, right? It thinks that I'm trying to write an identifier, which is not necessarily accurate, but it's given it its best shot, right? Okay, and so we recover from that error by typing a character, and then this goes back to a template literal, which is now correct, right? And same thing here, so I open up a multi-line, right? And it thinks that this is not valid TypeScript, which is correct, and it thinks I'm typing a it thinks I'm typing a regular expression pattern, right? So it thinks I'm kind of doing something like this, regex equals, hello, right? Something like that, which makes some sense, given that this is a slash. This could very easily be regular expression. It just so happens in this case I wanted a comment, right? And so once I close this, okay, it recovered from the error, and now it recognizes this thing as a comment. All right, so, once we sort of have this tree, of course, we've spent a lot of time talking about syntax highlighting, but that's not the only thing you could do with this, right? So, of course, there are other features of text editors besides, like, showing you colors for, like, oh, this is the color for a parameter or an identifier, or this is the color for the return statement, etc. You may also want to do other things, right? So, for instance, maybe I wanted to implement something like folding, right? So I don't have folding turned on. Or if I do, I don't know how to use it, but it's not a feature I've ever used. But essentially, folding is the idea that like, oh, maybe I want this function definition. I don't want to look at this body all the time. I just want to only look at it if I'm interested, but I do want to see this function at all. So maybe I'll kind of collapse this, right? And of course, you could have nested folding where maybe you have like a class with a few methods, and maybe you fold the class and then you open the class up and then you have to open all the methods or whatever. But again, the idea is you can quickly see maybe a large file full of lots of definitions, but without like seeing the specifics of their body unless you're interested, right? Most text editors probably implement folding using indentation, right? So for instance, Vim can come in here and it says, oh, I recognize that here's a curly and everything below the curly is indented a few characters, right? And so if I were to fold this, it can do that sort of on a heuristic or rule-based thing. But maybe actually right here, it's kind of messed up because of the way I wrote this function, which is still valid TypeScript, right? Foo and second are actually in line with this, and it might kind of collapse this in addition to that, or maybe some editors would, where again, tree sitter is not subject to this, right? If we implement our folding using this tree sitter data structure, right, we know where in the tree the body of the function is, right? So here is the body node, right? And this is the thing we know to omit when we from visuals when we fold, right? Some other things we can do, so again, because we're consuming this tree, right, we can use this to do like kind of smarter selection, right? So for instance, right now I'm on this value string, which is in this like large structure, right? This is part of an object, and then that object's in an array, which is in another object, which is a return statement, which is in the body, function, etc. So I can do something like I want to select my current node, right? So right now I'm selecting this string, and I can say, well, I want to select the parent, which is like this key value in here, and then I want to select that parent, which is the object. And so I'm actually kind of like using this tree and ascending it, right? And getting very accurate selection, right? And I can maybe go to the one I want to delete this thing, and I can delete that very accurately, right? Without like basing this on regular expressions or lexical properties like select, around square brackets or something like this. So tree sitter is not particularly, because it's actually doing real parsing, it's not subject to problems with like long lines, right? Where maybe if you ever open a minified JavaScript file, which is, all one line, maybe you'll get some syntax highlighting at the beginning, but it kind of crashes after that if it works at all. A tree sitter will actually parse that and colorize it no problems. And again, minified files might be quite large. They might be megabytes in some cases, right? The tree sitter should be able to, in like sub-millisecond, or unnoticeable amounts of time, parse that for you. Tree sitter may also be really useful if you have like some repo or code base specific rules. Like maybe if you're working on a legacy JavaScript, I keep using JavaScript code bases as examples, but maybe you're working on a legacy code base in JavaScript that uses a lot of jQuery. Maybe you want to highlight the identifier $sign in some particular way, right? So again, I'm going to be doing some kind of jQuery operation, hello, right? And I want to highlight this identifier in a particular, maybe as red or something. You can easily do that. You can kind of consume all of the identifiers, right? We have these nodes and they have types, right? That where the value is like $sign, right? And maybe highlighted in a particular way. And I kind of want to end the video with just a brief discussion of what tree sitter isn't and where it may not suffice, right? So there's a lot of discussion these days about things like language server protocols. And again, it's the same kind of idea where you have something that's a little higher level where it actually understands the language that you're writing rather than just the text, right? So it can do things like, language server protocols can go to definitions. They understand like modules or maybe project-wide features. but they may also be slow, right? They may have a lot of dependencies. They may have some process that is required to be run in the background. TreeSitter is better for like kind of within the same file operations, right? If you just want to like select things, highlight things, move, change nodes, obviously, anything we talked about in this video is kind of on a file basis, right? TreeSitter is going to be better, right? Because it's going to be fast. It's going to be sub-milliseconds for some of these kinds of operations, for instance. You don't need to run anything in the background, and it'll just work out of the box without any additional dependencies. That is a pretty in-depth discussion of TreeSitter, but I think it's an exciting piece of technology. Most of this stuff has been around for a while. Again, I didn't talk about how the algorithm of how it actually works, but I think it uses like LR parsing or whatever. This has been around since the 60s. We might have slightly modified it to be more general to handle sort of the kinds of grammars that programming languages use today. But and again, we might have modified it again to handle like error cases better and be more incremental. And I think some of that research is as recent as the 90s. But again, I think this is going to be really cool, and it really comes down to how editors consume these parse trees, right? So these syntax trees, it's going to come down to like how nice are the color schemes? Are they like really, really syntax aware? And do they show you cool things like, types are always the same color? Or, do I have like nice programming keyboard shortcuts for like moving nodes around and maybe changing the order of arguments? Do I have the capability to consume this tree in a nice, convenient way? And I think that's really what's happening now. If you want to try this out, you can try it out in NeoVim Nightly. I know has this. You'll have to like get it from GitHub or whatever. I think the Atom text editor has been using TreeSitter for a number of years now. You'll have to look up for your specific editor if it has TreeSitter support and how exactly to enable it. Well, thanks for watching. This has been a great little video. I love DevTools and programming language. So this is like, my bread and butter. I love talking about this stuff. So thanks for joining me.